When you see a skyscraper or one of those massive container ships, do you ever just stop and think, how? Our world is built by these giants, these enormous cranes lifting just impossible weights. But behind all that brute force, there's a secret intelligence, a technological brain making it all happen. And today, we're going to go inside the brain of the crane.
Because that's the real question, isn't it? It's one thing to lift 100 tons of steel. It is a completely different ballgame to place it exactly where it needs to go, down to the millimeter, without causing an absolute disaster. That single question, right there, is what we're going to answer in this explainer.
So here's our roadmap. First, we'll get a handle on the basic problem of moving all that weight. Then we're going to meet the incredible tech that acts as the crane's brain. We'll break down its three core principles: safety, installation, and programming. And then we'll zoom out and see how this kind of hidden tech is quietly shaping our entire world.
All right, let's dive right in with the central challenge. At the very heart of any modern crane operation, there's this fundamental tension, this battle between raw, almost unstoppable power and the absolute need for delicate, hair-splitting control.
Just think about it for a second. An operator, they push a joystick or a button. That simple little action has to be translated, somehow, into the perfectly smooth motion of a multi-ton steel beam. If it's too fast, you get this huge, dangerous swinging motion. Too jerky, and you could damage the load or even the crane itself. So the problem isn't just about moving something, it's about moving it perfectly.
So, how do you solve that balancing act? It seems almost impossible. Well, you give the crane a brain. And in the world of heavy industrial lifting, that brain is an amazing piece of technology called the impulse drive.
And this is it. I know, it might just look like some generic industrial box, but this red controller is the absolute nerve center. It's the critical link between what the operator wants to do and what the crane's powerful motors actually do. This is the tech that turns a simple human command into perfectly controlled, powerful motion. So what is this thing really? Well, it's an adjustable frequency drive, or an AFD. Now, the easiest way to think about it is to imagine a super sophisticated light dimmer switch combined with your car's gas pedal, but for a gigantic electric motor. See, it doesn't just switch the motor on or off, it precisely tells it how fast to spin and with exactly how much force, making sure every single movement is incredibly smooth and controlled. And what's really fascinating here is that it's not a one-size-fits-all solution. You've got the G+ model, that's kind of the workhorse for your standard day-to-day movements. But then, you have the VG+. That one uses a much more advanced system that gives it constant feedback from the motor itself. This allows for these tiny, micro adjustments that you absolutely need for the most delicate, high-stakes jobs. It's like the difference between just driving a car and performing surgery.
Okay, so now that we've met the brain, let's get into the three principles it lives by. And the first one, the most important one, is safety. It's non-negotiable. Because when you're dealing with this much power, there's absolutely zero room for error. Safety isn't just a feature, it's the entire foundation.
Just listen to this. This is a direct quote from the instruction manual. They do not mince words. This one sentence tells you everything you need to know about the stakes involved. We're not talking about a dented piece of equipment. We are talking about life and death. Every single rule is built on this grim reality.
And this slide just lays it all out, plain and simple. There's a very clear, very strict hierarchy. Danger is for the absolute worst case, no way out scenarios. Warning is for situations that could be lethal, and then caution is for lesser but still pretty significant risks. Every hazard is categorized, and every single one is respected. Okay, moving on to our second pillar. Now, you can have the most advanced brain in the entire world, but if its environment is wrong, it's just not going to work right. The physical setup, where and how this thing is installed, is every bit as critical as the software running inside it.
Take a look at this. It seems so simple, doesn't it? The drive has to be installed vertically. But why? Well, it all comes down to heat. This thing generates a lot of it, and this vertical setup is what allows the heat to escape properly through those fins. If you mount it sideways, it could overheat, fail, and probably at the worst possible moment. It's a perfect reminder that in high-stakes engineering, the tiniest details can have massive consequences.
And it's not just about orientation. This electronic brain is sensitive. It's got to be protected from everything. We're talking extreme temperatures, rain, dust, even heavy vibrations. You basically have to create this perfect little protected bubble for it to live in just to make sure it can do its job reliably every single time.
All right, this brings us to the third and final pillar, the intelligence itself.
This is where the real magic happens. It's all about the smart programming and the advanced features that are built right into the drive from the factory.
This is where you really see how smart this thing is. For instance, a feature like Swift Lift knows when there's no load on the hook, so it moves way faster, saving precious time on every single lift. Anti-shock is like a suspension system. It absorbs all those jarring movements. And something like slack cable detection. That is a critical safety feature that stops the cable from unspooling into a dangerous mess if the load gets caught on something.
So really, you shouldn't think of these as just settings in a menu. They're more like pre-programmed skills. The drive is built to be intelligent, to anticipate problems, to optimize how it works, and to react to changing conditions instantly. All of it makes the whole operation faster, smoother, and above all, safer. So let's zoom back out for a minute. We've gone really deep into this one piece of tech, but its story is really part of a much bigger picture, a story about the world we live in.
Here's the big takeaway. Our world runs on these hidden brains. The impulse drive is just one example. You don't see it when you look at a building, you don't see it when you look at a bridge, but it and countless other devices just like it were absolutely essential to putting it there. They are the invisible, intelligent workhorses of our entire world.
And that really leaves us with a final thought, doesn't it? From the anti-lock brakes in your car to the ridiculously complex systems that manage our power grid, we are literally surrounded by specialized, unseen technology doing these critical jobs. It makes you wonder, what other hidden brains are out there, quietly and precisely making everything work?